Hello, welcome to ANS Solver. This is the fifth question of the paper. So I know the integration of 3x square plus 4 cos 2x minus sin x, okay, is equal to 2 with the limit 0 and a. And I need to show that that can be written in the form is this. So I start with integration. The integration of 3x square is simply 3x cube over 3. Correct? Basic integration plus the integration of cos. The integration of cos you need to know is simple, sine. So I can write this as 4 sine 2x over, it's always whenever we have a coefficient here for x, I always tell you that's the easiest way to remember it. Just write 2 down. Now the integration of a sine x is minus cos x. So that will change to plus cos x here. Now I have my limits of basically 0 and a, which is equal to 2. So now what I can do is I can write this basically as a cube, okay, plus 2 sine 2a plus cos a, okay, minus, I know when I put 0 in the place of x here and in the place of x here, I'll get 0. So I can write this as 0 plus, and I know when I do cos 0, I'll simply get 1, correct, which is equal to 2. So now I can basically write this as a cube plus 2 sine 2a plus cos a minus 1 equals to 2. So I can basically write this as a cube plus 2 sine 2a plus cos a, which is equal to minus, when minus 1 goes to the other side, this will become 3. So I can write this as a cube equals to 3 minus 2 sine 2a minus cos a. So I can basically write this as a equals to the cube root of 3 minus 2 sine 2a minus cos a, which is basically the final answer and what we needed to prove in the question. Now, using the equation in part 1, show by calculation a lies between 0.5 and 0.75. So we need to write the same equation but in the form something like this. A minus, get everything to one side. Okay, the cube root of 3 minus 2 sine 2a minus cos a. Okay, you don't need to write equal to 0 for now. Now I can say my a is 0.5. Now in the equation just put 0.5 minus the cube root, okay, of 3 minus 2 sine 2 into 0.5 minus cos into 0.5. Just let me just, yeah, okay. So now what I do is I just write this on the calci. Okay, just make sure you're on the radian mode. I know they haven't specified anywhere, but just make sure whenever we perform iteration, okay, you should make sure you're on the radian mode. Okay, so when I solve this on the calci, I get my answer as, just solving it, just give me 1 second. Yeah, so I get my answer as negative 0.2602. Okay, now what I'll do is I'll take my a as 0.75. Okay, now in the same, on your calci, just remove 0.5 and write 0.75. Okay, so when you do that on the calci, you get your answer basically as 0 point, which is positive 0.10103. So you should always look for signs. Write this as negative, this is positive. We can only say a lies between 0.5 and 0.75, okay, if there's a change in sign between them. So you can just simply write change in sign, okay, hence verified. Got it? So this is how we do the verification. Now use an iterative formula based on equation part 1 and find the correct value of a to 3 significant figures. So we can write our equation as a with n plus 1 equals to the cube root, okay, and what was our equation? Cube root of 3 minus 2 sine 2a, okay, minus cos a. So now what I can simply do is, my first step of iteration is always taking my n as 0. So I can write this basically as a1 equals to the cube root of 3 minus 2 sine 2. I know if this is n plus 1, this is n and this is n. Okay, that means if I take my n as 0, this becomes a0. And my a0 can either be 0.5 or 0.75 because I know a lies between them. So I can simply write this, let me take this as 0.5. You take any, it's totally fine. You get the same answer. Okay. Now what you do is, you write exactly this, okay, on the calci. Okay, so when you do this on the calci, just even I'm writing it, just give me 1 second. When you solve this on the calci, you get the answer as 0.760288. You get your A2. For A2, what you need to do is simply, in the place of 0.5, remove 0.5 and click on the answer button. It will basically take this value. Okay, remove 0.5 and click on the ANS button, the answer button. Okay, so when you do that, you get your answer basically as 0.65256. Now for A3, don't need to do anything. Just click on equal to. So you get 0.65079. Now for A4 in the same way, click on equal to get 0.65119. For A5, again click on equal to. You can just keep on, spamming the equal to button, okay, and when you see, you get the same answer over and over again. So you can simply say, from the last 3 iterations, the answer has been recurring. So this is my final iterative value, because how many ever times I click on equal to, this is my final answer. So my final answer to 3 significant figures is 0.651.